Hello everyone, and thanks for watching Edupedia World Videos. In this video, we'll discuss solutions to problems in Paper 1 of the 2014 JEE Advanced Mathematics paper. So let's start with the first question, which is number 41. We are given that M and N are two 3x3 matrices such that Mn is equal to Nm. And m is not equal to n squared, but m squared is equal to n to the power 4. And we are given 4 options. So what does this tell us? M squared is n to the power 4. M squared minus n to the power 4 is 0, which means m minus n squared times m plus n squared is 0. And we know m is not equal to n squared, so the only option left is m is equal to minus n squared. Right. Some people actually might look at this directly and in a hurry go m squared is n to the power 4, so m is plus minus n squared, which is the same as this equation, but when you're working with matrices you need to be a little bit more careful and make sure you take things to one side and don't multiply on different sides in the LHS and RHS. Just be a little bit extra careful with matrices. That's why I took it to the other side and factorized them. Right, so m is minus n squared. Now, when you're dealing with problems in which more than one choice may be correct, the best way to do it is by looking at each option as a true or false option. So option A says the determinant of m squared plus mn squared, which is just m times m plus n squared, and this is 0. And we know that the determinant of AB is equal to the determinant of A multiplied by the determinant of B. Right, so that means this is true. Option B says there is a 3x3 non-zero matrix such that m squared plus mn squared u is the zero matrix. Yes, there is a non-square matrix like this because the term we have is again m into m plus n squared into u. Right. And are there non-zero matrices for which this would be 0? Of course there are, because the determinant of this is 0, which means there is no inverse. Right. If there was an inverse, we could multiply this by the inverse on the left side, and this is equal to 0 would give u is equal to 0. Right. But that rule is not valid. The rule that AB is equal to 0 implies B is equal to 0 is only true if A has an inverse. Here it does not have an inverse, so this does not mean U is necessarily 0. Right, so there could be a non-zero matrix U, which means this is true. Option C is that determinant is greater than 1, which cannot be true if B is true, so this is false. Option D says that if m squared plus mn squared u equals the 0 matrix, then U is the 0 matrix. This is the opposite of B. This would be true if this matrix had an inverse, but since its determinant is 0, it does not have an inverse. So option D is not true, it is false. So the answer to 41 is A and B. Let's do the next one, 42. We are given there are two functions f and g whose domain is 0 and 1, and the maximum value of f of x is equal to the maximum value of g of x when x is between 0 and 1. So if we were to draw the graph, let's say this is that value 0 and 1, so that means f dash x is 0 at this place, right? And this also means that fx has the derivative f dash x, which is 0 at this place. And also gx has a derivative g dash x, which is 0 at this place. So it might be something like this. This figure assumes that they both have the maximum value at the same x. Right, they both have the maximum at the same x, and that's not wrong. That's not necessarily true. I read the question wrong. What we are given is between 0 and 1, let's say there's this value of y. That is the maximum value of both fx and gx between 0 and 1. Let's say fx approaches that value at this point. So the derivative is 0, and in the immediate neighborhood of that point, this is how it will be. Gx might have the same maximum value within 0 and 1, but it could be at a different point, right? Because if we look at the condition, between x and 0, 1, the maximum value of fx, that is this. is the same as the maximum value of gx between 0 and 1, which is true in this case, right? But even in this case, you have to have something like this, right? It doesn't need to meet at 0 here, but they have to meet at some point. You can't, if it were to happen, for example, that this went like this and this went like this, then these wouldn't be functions, right? If it's going like this, then it has to go like this, which means these two functions do have an intersection point at some point between 0 and 1. That means fx is equal to gx for some c between 0 and 1, right? And if this is true, then we can see that option A and option D are immediately true, right? But we can't say anything about B and C because they are different terms. Now B and C we can directly dispute by taking the function to be like this, right? Just take the function to have a constant value which is that maximum value. In that case, fx and gx is constant. So f of c whole squared plus f of c will not be g of c whole squared plus 3 times g of c, right? That 3 factor makes the LHS different from RHS, and same for c. So b and c can directly be eliminated because this function fx also satisfies the whole thing, right? So if it's valid for all fx and gx, then it's valid for these constant functions. So the answer to this question is A and D. Let's look at 43. We have fx given by fx is equal to from 1 by x to x e to the power minus t plus 1 by t dt by t. So first of all, we can see that f of minus x, f of 1 by x will be 1 by x means x, and this is 1 by x, and this whole term is exactly the same, whatever is here. So this is equal to negative of f of x. So this is the one property fx has. F of 1 by x is the negative of fx. From that we can see, if we look at options A, B, C and D, that option C is directly true. Fx plus f of 1 by x is 0. And it also means option D is true, because if f of 2 to the power x is odd, that means f of 2 to the power x is equal to the negative of f of 2 to the power minus x. But what is 2 to the power minus x? It is just 1 by 2 to the power x, right? And we know this is true because f of 1 by x is minus fx, just 2 to the power x takes the value of fx, so D is true. Between A and B, to decide whether it's increasing or decreasing or both, we need to look at the derivative of fx, because we are asking whether fx is decreasing or increasing, right? So if this is fx, we know how to take f dash x. It will be the term within the integral multiplied by the derivatives of the limits, right? So first it will be e to the power minus x plus 1 by x divided by x into the derivative of x, and the next it will be minus e to the power minus x plus 1 by x into the derivative of 1 by x. So plus, and here it will be 1 by x squared, right? So this is x cube, which is equal to, we can put x squared here, and this is x cube, x squared plus 1 by x cube e to the power minus x plus 1 by x, right? And we can see that between 1 and infinity, this is clearly a positive quantity, right? So A is obviously true, right? But B cannot be true, because between 0 and 1 also this is a positive quantity. This is positive between 0 and 1. E to the power something is always positive, right? So B cannot be true, so B is false. Which means the answer to this question is A, C and D. Let's look at question 44 now. We have f of x is equal to x to the power 5 minus 5x plus a. Right. What is f dash of x? It is 5x to the power 4 minus 5, which is 5 times x to the power 4 minus 1, which is 0 at x is equal to plus minus 1. F double dash x is 20x cube. And 20x cube is negative at x equal to minus 1, means x is equal to minus 1 is a maxima, and x is equal to 1 has f dash x positive, means it is a minima. So if we were to plot the curve, and this is for all of x, between all of x, minus 1 and 1 are the only 2 points. Here we have a maxima, here we have a minima. Right, everything else between these two is 0. If x is less than 1, if mod x is less than 1, then this term is negative. So between 1 and minus 1 is negative. It doesn't matter what it is, it's negative. And greater than 1 is positive, and less than minus 1 is positive. So something like this, right? This point will be a, because fx at x is equal to 0 is a. Now what are these 2 points? What is the value at x is equal to minus 1? If x is equal to minus 1, fx is minus 1 plus 5, that is 4. 4 plus a, right? So this is a plus 4. And similarly, if you take x is equal to 1, 1 minus 5 plus a is a minus 4. So this is a minus 4. Right? This is for different values of a. And this is a. Now what happens as you change a? If you increase a, this point is a, this point goes up. That means this whole graph moves upwards if you increase a, and if you decrease a, this whole graph moves down. Right? What happens when a is, let's say, 10? Then what is 10 minus 4? That is 6. That means the minimum value becomes 6. So the graph, instead of becoming like this, becomes something like this. It is moved up a little bit, where this will be 6. And it never ever touches the x-axis. Right? Similarly, if you move it down after a point, it will become like this, and it won't touch the x-axis here. When will that happen? When a plus 4 becomes 0. Right? So as long as mod of a is less than 4, that means a is between 4 and minus 4, you will have 3 points of intersection. But if mod of a is greater than 4, that means a is greater than 4, in which case we'll have something like this. The minimum point will be a positive point. And if a is less than minus 4, the maximum point will still be a negative point. So it will be like this. And you'll have one solution. If it is like this, then it will eventually have to touch it somewhere here. And if it is like this, it will go up, but it will come back, and here it will have to touch someplace, because it can't, f dash x can't be 0 anywhere else. So just look at this graph and move it up and move it down and see, between a certain range, it has 3 solutions. Above or below it, it has only 1 solution. So the answer to this question will be option B and option D. Option A says 3 roots if a greater than 4. That is not true. Option B says 1 root if a greater than 4. That is true. C says 3 roots if a less than minus 4. Not true. 3 roots if a is between minus 4 and 4, which is option D. Right. Question 45. You have f of a comma b, f going from a to b to 1 to infinity being a continuous function, and gx is given to be 0 if x is less than a, integral a, say a to x f of t dt, a less than equal to x less than equal to b, and a to b f of t dt x is greater than b. So when x is just greater than b, it is a to b dt. What about when x is just less than b? This is still a to b dt, right? Which means approaching b from either the left or the right, the limit is the same, right? I can write this explicitly if you want. Limit x goes to b plus gx is of course what it is, a to b f of t dt, because it doesn't change. Limit x goes to b minus gx is equal to a to x f of t dt, where x is b, right? So basically a to b dt, so they are the same. So at b, g is continuous. Similarly, when x is 0 here, the integral, when x is a here, just a little bit more than a, the integral is from a to a, which is 0. And just less than a also it is 0. Which means we know g is continuous at both a and b. Now what about g dash x? If we want to know whether g is differentiable or not, we need to look at g dash x. So g dash x is equal to 0 if x is less than a, because it's a constant, the derivative of that is 0. It is equal to, if you differentiate this, you'll get f of t into the derivative of x, which is 1. So f of t, right, between a less than x less than b, right? And here what do you get the derivative? The derivative is again 0, x greater than a, x greater than b. And you see f of t is given to lie between 1 and infinity, which means f of t can never be 0. So obviously the derivative at the left hand and the right hand limit of a are different, and the left hand and right hand limit of b are different. So it is not differentiable at either a or b, right? So option A is true, continuous but not differentiable at a, and option C is true, continuous but not differentiable at b. Right, option B is false and option D is also false. It is not differentiable at both of them. Let's look at the next question. We are given f is a function defined from minus pi by 2 to pi by 2 to r, given by f of x is equal to ln cube of sec x plus tan x, right? And we are asked about some properties of fx, whether it's odd or even, onto or 1 1. So let's look at whether it's odd or even. For that we need to look at f of minus x, that is equal to ln cube of sec of minus x is just sec x, right? So sec x, and tan of minus x is minus tan x, right? We know sec square x minus tan square x is 1, so we can also write this as ln cube of 1 by sec x minus tan x, sec x plus tan x, right? Because sec x plus tan x into sec x minus tan x is sec square x minus tan square x, which is 1. And this, of course, now from this you can see already, ln cube of minus ln cube of minus 1 whole cube will be minus 1, so minus ln cube of sec x plus tan x, which is minus f of x. So we know f is an odd function. So a is true and d is false. Let's look at b and c, right? To look at whether or not it's a one-to-one function or not, we need to look at f dash of x, which will be 3 ln square of sec x plus tan x into 1 by sec x plus tan x into the derivative of sec x plus tan x, which is sec x tan x plus sec square x. Now we take one sec x common, sec x plus tan x and sec x plus tan x cancel, right? So what we are left with is sec x. Because you take sec x common from this, you are left with sec x plus tan x, which cancels with sec x plus tan x, right? Now f dash x, when x is between minus pi by 2 and pi by 2, cos x is positive, so x is positive, sec x is positive, and ln is positive, right? Because sec x plus tan x is also positive between minus pi by 2 and pi by 2. Sec x plus tan x can be written as 1 plus sin x by cos x, right? And anyway, in this case it doesn't matter because this is ln squared, right? So even if ln is negative, ln squared is positive. So this is positive. We know sec x is positive, which means f dash x is greater than 0 for all x between minus pi by 2 to pi by 2. So we know this. Now let's also look at the limits just in case. What is f of minus pi by 2? Right. So sec x plus tan x we can write as 1 plus sin x by cos x. What is the limit of this? X goes to minus pi by 2. You can differentiate both of them. So it will be cos x by sin x. Cos of minus pi by 2 is 0. So the limit is 0. So when x goes to minus pi by 2, this term goes to 0, which means the log of this term goes to minus infinity. So this is minus infinity. F of pi by 2, this term goes to infinity as x goes to pi by 2 because tan x goes to infinity. That means this term goes to positive infinity. So it goes from minus infinity to infinity with f dash x being greater than 0. So not only does f dash x greater than 0 mean it's 1 1 throughout the domain, but it also covers the entire range. So it is also onto. So B and C are both true. So the answer is A, B and C, not D. Right? Let's look at question 47. We are given two lines, and I'll just write them in a better form just in case. So y is equal to x, z is equal to 1. This can be written in the standard form as x minus 0 by 0 is equal to y minus 0 by 0 is equal to z minus 1 by 0, right? So these two are 1, right? Basically this is k and this is k and this is 1, k. The second equation, y is equal to minus x and z is equal to minus 1, can be written as x minus 0 by 1 is equal to y minus 0 by minus 1 is equal to z plus 1 by 0 is equal to L. And we are given a point P which is lambda comma lambda comma lambda. What are the general points of these two? The general point for this would be k comma 1, and here it would be k comma minus k comma minus 1, right? The two general points. So Q is the perpendicular, PQ is the perpendicular on the first line, right? So what is the vector PQ? That will be lambda minus Q will just be a random point on this line. So lambda minus k, lambda minus k, lambda minus 1. This is the line PQ. We want this to be perpendicular to this line. We can already see that this line's direction cosine is 1i plus 1j, right? So this vector dot with I plus j should give me 0 because they are perpendicular, right? Which means 2 times lambda minus k, because you have lambda minus k into 1 plus lambda minus k into 1 plus lambda minus 1 into 0 is 0, which means lambda is equal to k, which means the point Q is lambda comma lambda comma 1. Similarly, we can get the point R. The vector PR will be lambda minus k, lambda plus k, and lambda plus 1, and the dot product of this with I minus j should be 0, because the direction cosine of the second line is 1 I cap minus 1 j cap plus 0 k cap, right? Obviously by root 2 because it has to be the unit vector, but we are equating it to 0, so that doesn't matter, which means lambda minus k into 1 plus lambda plus k into minus 1 is equal to 0, which gives me minus k and minus k cancels, lambda is equal to 0, which means this point is 0, 0, minus 1, R. So we have P, Q and R. Now we are given that QPR is a right angle triangle. That means QP, this vector, is perpendicular to PR, right? QPR is a right angle triangle, but it means QP is perpendicular to PR, right? So we can just see what QP and PR are right now directly. I'll just rub the upper part. QP is 0 I cap plus 0 j cap plus lambda minus 1 times k cap, right? And PR is lambda I cap plus lambda j cap plus lambda plus 1 times k cap. And these two are perpendicular, so the dot product of these is 0. So which gives me lambda into 0 plus lambda into 0 plus this is equal to 0. So lambda minus 1 into lambda plus 1 is equal to 0, which means lambda is equal to plus minus 1, right? Now this is actually why IIT JEE is a more difficult paper than the average paper, because a lot of students would naturally see this and put in both B and C as the option, but the answer is only C. B is not the option, because B, which is that lambda is equal to 1, means that this point Q is 1, 1, 1, P is 1, 1, 1. That means P and Q coincide. That means the point P lies on the first line, right? So it's sort of like this is the line and this is the point P, and we are saying this angle is 90, but lambda is equal to 1 gives us that these two are the same point. So this angle doesn't even make any sense. So lambda is equal to 1 is not a proper value, because QPR would not even be an angle. Of course, in this case, this term would be 0. See, you can take this vector, this point and this point and this point, right? This line can be perpendicular to this line. That would give you a particular value. But also, if these 2 points are the same, then this vector dot this vector will be 0, because this vector is 0. It would have nothing to do with perpendicularity, right? So this is the important point in this question. B is equal to 1 means that the point P lies on the line, which means that the point P and the point Q are the same point. Lambda is equal to 1 means these two are the same point, which means this is a trivial question, so that should not be an option. So the answer is C. Lambda is equal to minus 1, not D. Right, so this was a difficult question because of this concept, in my opinion. 48. And it doesn't help that 1 was one of the options. If 1 was not one of the options, then you could maybe say they didn't give the option or whatever. But because 1 is the option, most students, in my opinion, would immediately put B and C. Right. 48, you have X, Y, and Z are 3 vectors, each of magnitude root 2. So we can just write mod X is equal to mod Y is equal to mod Z is equal to root 2. And the angle between each pair of them is pi by 3. A is a non-zero vector perpendicular to X and Y cross Z. Right. So first of all, so then what we can say is A is equal to K times a random vector perpendicular to X and Y cross Z. So the vector perpendicular to X and to Y cross Z will be X cross Y cross Z. This is perpendicular to both X and Y cross Z. And we can use the BAC-CAB rule to write this as Y times X dot Z minus Z times X dot Y. Right. So this is one vector, and the vector A is perpendicular to both of them, means it is parallel to this vector. Right. And we know X dot Y, X dot Z values already. From this we can calculate easily. X dot Y is equal to mod X mod Y cos of 60 degrees. Right, because the angle is 60 degrees. Cos 60 is half, mod X and mod Y are root 2, so X dot Y is 1. Similarly, Y dot Z is 1. Similarly, Z dot X is 1. Right. So what this says to us is lambda times a, whatever the lambda vector might be, is equal to y minus z, because x dot z is 1 and x dot y is 1. Similarly, we are given b is a non-zero vector perpendicular to y and z cross x. So it is y cross z cross x, which we can write from the BAC-CAB rule as z times x dot y minus x times y dot z, which is again z minus x. So let's take another vector mu, another scalar mu. So mu times b is equal to z minus x. These two things are given to us, right? Now we can just start putting in options and seeing. So let's see for options A, B, C and D. You know what? Actually, I've done this before, this question, and it actually works easier if we take lambda to be this and mu to be this, right? I hope that won't confuse you. It doesn't matter. When these two vectors are parallel, they are related by a factor of any number, and that number doesn't matter. If we do it on this side, the calculations will be easier. That's just all that it is. We'll avoid fractions, right? So we just write these here and I'll rub the rest. A is equal to lambda times y minus z, and b is equal to lambda times or another mu times z minus x. And we look at all the four options individually. So A says that b is equal to b dot z times z minus x. Right, so let's put the value of b from here. Let's solve the RHS. So mu times z minus x dot z, this is the vector b dot z times z minus x. What does that come out to be? So mu times z dot z is 2, because mod z is root 2, so mod z square is 2, and minus x dot z is 1, we already know that, times z minus x. So this is basically 2 minus 1 is 1, so mu times z minus x, which is actually b, so the first statement is true. The second one says a similar thing about a. So we look at a dot y times y minus z and see if it's equal to a. This is equal to lambda times y minus z dot y times y minus z, which is equal to lambda times y dot y is 2, because mod y is root 2, minus z dot y is 1, y minus z. So it comes out to be lambda times y minus z, which is indeed a. So option B is also true. Right. Option C asks us what is a dot b. So a dot b is lambda mu times y dot z, y minus z dot z minus x, which is equal to lambda mu times y dot z is 1, minus z dot z is minus 2, minus y dot x is minus 1, plus x dot z is plus 1. So it is minus lambda mu. Let's see what the right hand side is. A minus of a dot y times b dot z. So a dot y is equal to lambda y minus z dot y, which is equal to lambda times y square is 2 and y dot z is 1, so 2 minus 1, which is 1. So a dot y is lambda. Similarly, b dot z is mu, so it is, because it is mu times 2 minus 1. So minus a dot y times b dot z is minus lambda mu, which is again this. So option C is also true. Let's look at option D. Option D is just the negative of option B. And if A is equal to what is said in option B, then it cannot be what is said in option D. So obviously D has to be false because D and B simultaneously cannot be true. So the answer to this question is A, B and C. Let's move on to question 49. We are given a circle S passing through 0, 1 being orthogonal to two given circles. So let's just assume the standard formula for the circle: x squared plus y squared plus 2 alpha x plus 2 beta y plus c is equal to 0. We are given that it passes through 0, 1, which means 2 beta plus 1 plus c is equal to 0. This is one equation which is given to us, right? And there are two more circles which are given, which it is orthogonal to: x minus 1 whole squared plus y squared is equal to 16, which can be written as x squared minus x squared plus y squared minus 2x minus 15 is equal to 0. And the other one is x squared plus y squared is equal to 1. So this given circle, which has three unknowns, alpha, beta and c, right? Now I don't know why I took c, I should have taken gamma, but that's fine. We have one relation because it passes through 0, 1. Now we have two more relations by orthogonality. We know what the relation for orthogonality is: 2 times g1 g2 plus f1 f2, where this is g and x, or at the role of alpha and beta, is equal to c1 plus c2, right? And we've written both of those in that form. So with orthogonality with the first one, we'll suggest 2 times g1 is alpha and g2 is minus 1, so minus alpha, and f1 plus f1 is beta but f2 is 0, right? So just minus alpha is equal to c minus 15, right? c1 plus c2, which means I'll write the other equation here: c plus 2 alpha is equal to 15. And orthogonality between this and this one, g1 and g2 and f2 are both 0, so the LHS is 0. The RHS is, we can write this as minus 1 is equal to 0. C minus 1. C minus 1 is 0, means C is equal to 1. C is equal to 1 means alpha is equal to 14 by 2 or 7. And C is equal to 1 here means 2 beta plus 2 is 0, or beta is equal to minus 1. Right. Now we are asked a few questions. What is the center? The center is alpha comma beta, or the center is minus alpha comma minus beta, right? Because x minus alpha whole square would give minus 2 alpha x. So that is minus 7 comma 1. So option C is correct and option D is not. And then we are asked the radius, right? We know what the radius of a circle is. It's root of alpha squared plus beta squared minus c, which is root of 49 plus 1, and c is 1, so minus 1, which is 7. So the radius is 7, which means the option B is correct. So the answer is B and C. Question 50. M is a 2 cross 2 symmetric matrix with integer entities. So if this is A, this is B, this is C and this is D, if it is symmetric, this also has to be B. Right, this is the standard form of M, and we are given A, B and D are integers. Then when is M invertible? That is asked. Right, so M is invertible if determinant of M is not 0. That means AD minus B square is not equal to 0. Right, or AD is not equal to B square. And this is invertible if this condition is true. And what they are saying is the first column of M is the transpose of the second row of M. The first column of M is A comma B is the transpose of the second row of M. The second row of M is B comma D. The transpose of that is B comma D. Right, but I'm not writing it in that sense. Okay, I'll just write it properly, that actually be more clearer. The first column of M, AB, if it is the transpose of the second row is BD as a row, so BD. If this is true, then clearly A is equal to B and B is equal to D, which means AD is equal to B square. So then it will not be invertible, so A is false. Similarly, second row of M, BD, is the transpose of the first column. Even in this case, A is equal to B is equal to D, and it is not invertible. We want it to be invertible, so B is also false. Then M is a diagonal matrix with non-zero entries in the main diagonal. That means B is 0 and A and D are non-zero. Then this statement is true, which means M is invertible. So C option is true. And D option says the product of entries in the main diagonal is not the square of an integer. If the product of entries in the main diagonal is not the square of an integer, AD is not equal to B square, which means the determinant is not 0 and it is invertible. So D is also correct. So the answer to this question is option C and option D. Let's move on to the integer type questions now, starting with question 51. We are given A, B and C are positive integers and B by A is an integer. And A, B and C are in geometric progression. So we can just assume the numbers are A, AR and AR square. Right. B by A is an integer means that R is an integer. And not only is it an integer, A, B and C are positive, so it has to be a positive integer. This is the restriction on R. We are given the arithmetic mean of these three numbers is B plus 2. That means A plus AR plus AR squared by 3 is equal to B plus 2 or AR plus 2. We just need to solve this a little bit further. A plus AR plus AR squared is equal to 3AR plus 6, which means A times R squared minus 2R plus 1 is equal to 6, which means A times R minus 1 whole squared is equal to 6, which means R minus 1 whole squared is equal to 6 by A. Now after this, because these are integers, it's very limited. If R is an integer, a positive integer, R minus 1 has to be an integer. That means its square is an integer. That means 6 divided by A has to be an integer. But 6 divided by A can be an integer only for values A equal to 1, 2, 3 and 6. Right, if A has any integer value other than these, 6 by A will not be an integer and R will have no integer solution. What is R for all of these? If R minus 1 whole square is 6, then R minus 1 is equal to 36, or R is equal to, if R minus 1 whole square is 6, R is equal to root 6 plus 1. Right, R minus 1 is root 6, so R is root 6 plus 1. If A is equal to 2, 6 by A is 3, so it is root 3 plus 1. If A is equal to 3, it is root 2 plus 1. And if A is equal to 6, it is 1 plus 1 or 2. Right. If A is equal to 6, this is 1. R minus 1 whole square is 1, which means R minus 1 is plus minus 1. The one solution gives 0, but it's a positive integer, so R is equal to 2. Of course, these three are not integers, so it cannot be, which means A is 6 and R is 2. That is the only possible option. We are asked the value of A square plus A minus 14 by A plus 1, which is 36 plus 6 minus 14 by 7, which is 42 minus 14 is 28 by 7 is 4. So the answer to question 51 is the integer value 4. 52. We are given an n-sided regular polygon. I'll draw it for n is equal to 6. And we are given that the line segment joining every pair of adjacent points is blue and all the other line segments are red. So we just join all the points together. These all lie on a circle, which is just a way of saying they're a regular polygon. Right. And actually in this question they don't even need to be a regular polygon. But they are on a circle, which means they are a polygon. So the total number of lines with blue lines is the same as the total number of red lines. What is the total number of blue lines? It will be n. This is a blue line, this is a blue line, this is a blue line. Any line joining two adjacent points is a line, and if you have 6 points, you have 6 lines. So this is n. This is equal to the number of red lines. Now the number of red lines is interesting. That is all the other lines. So you take this point, it can't have a line with this and this, those are blue, but this line, this line, this line, all these would be red. So you take any point n and you are left with 3 other points. You can't take that point, you can't take the adjacent 2 points. N minus 3 by 2, because you count each of them twice. These will be the total number of blue lines, right? You take any point, it makes lines with all points other than 3. So n into n minus 3, obviously you don't want to take any number twice, so divided by 2. So this is the equation, which means n minus 3 is equal to 2, which means n is equal to 5. So this was quite a simple question. This is the formula I'm sure you've seen before. This is generally taught in most IIT JEE classes. Not this formula, this formula. The formula for the number of, basically the number of diagonals. Any line which connects two non-adjacent points. You take one point, then you can't take these 3. You take any other point and you join them. Let's look at question 53, which is also quite an interesting question. It's very simple in that all you need to do is calculate the number of arrangement. There's no hardcore mathematics here. n1 less than n2 less than n3 less than n4 less than n5, and their sum is 20. So what you do is you just start from the lowest possible numbers. 1, 2, 3, 4. Is there a fifth number which makes the sum 20? 1 plus 2 is 3 and 3 is 6 and 4 is 10. If you have 10 here, it makes the sum 20. Right. Now 1, 2, 3. Now you can have 5, right? This can only go above 3. If this is 1, this is 2, this is 3. This can only go above 3. So this can be 4, 5, 6 or something. What if this is 5? Then this is 9. Similarly 1, 2, 3. If this is 6, this is 8. Right. Now you can't have 1, 2, 3, 7 and 7 because this has to be greater than this. Right. So now 3 is out of the question. We have done all the ones with 3. So now we'll take this to be 4. Now if this is 4, this has to be at least 5. So if this is 5, what is this value? 4 and 5 is 9 and 1 is 10 and 2 is 12. So this is 8. That also means 1, 2, 4, 6 and 7. Right. Now we are done with 4. We can't take this to be anything else. So now what we'll try to do is we'll try to take 1, 2, 5. Right. But if we take this to be 1, 2, 5 and this is 6, 5 and 6 is 11. 11 and 2 is 13 and 1 is 14. So this has to be 6, which cannot work. That means there is no number beginning from 1, 2, 5. Right. I'll repeat this process once more so that you understand it. But right now we'll just solve the question. So now we have to go to 1, 2, 6. But if this is 6, this has to be 7 and 8. And again the sum is greater than 20. Right. That means there's nothing after 1, 2 which will work. So we actually have now to move on to 1, 3. And if this is 1, 3, this has to be at least 4, this has to be at least 5. Then what is this? 1 and 3 is 4 and 4 is 8 and 5 is 13. So this is 7. Right. But now we can't have 6 and 6. And if let's try 1, 4, then this has to be 5, 6 and 7 minimum. 6 and 7 is 13 and 5 is 18 and 4 is greater than 20. So we can't have 4. We certainly can't have 5 or 6. So now we have to go to 2. So 3, 4, 5 is the lowest possible combination after 2. 2 and 3 is 5 and 5 is 10 and 4 is 14. So this is 6. This is a possible combination. If you take 2, 4, obviously you can see 2, 3, 4, 5, 6 is the sum. So this will exceed. You can't take 3 with anything either, so this is the final possible thing you can take. So you have 1, 2, 3, 4, 5, 6, 7, 7 total combinations. Right, I'll just repeat the process once more. The condition you have is n1 less than n2 less than n3 less than n4 less than n5, and they are all positive integers, so they are at least 1. Right, so if we take the first number to be 1, right, we'll just start with the lowest number and keep moving up. The advantage is n1 plus n2 plus n3 plus n4 plus n5 is 20. So after a certain point, you will not be able to exceed n1 or any of the numbers. All these numbers will have an upper limit because they are all positive. So we start from the lowest point. 1, if this is 1, this has to be at least 2. And this has to be at least 3. And this has to be at least 4. And the fifth number can be anything such that the sum is 20. Right? So we make it 10. Now what we do is, if this is 1, this is at least 2, this is at least 3, this is at least 4. So we move on to the next case. We move on to 5. And that is also gives us the sum 20 if this is 9. We move on to 6, this gives 8. If we moved on to 7, we would have seen 1, 2, 3 and 7. The last number needs to be 7 in order for it to be 20. But the last number 7 does not satisfy this condition. So we move on to now this 3 becomes 4. Because this number was at least 3, so we try 3 and all higher values. Essentially what we do is this. Lowest possible value, for that we take the lowest possible value of this, for that we take the lowest possible value of this, for that we take the lowest possible value of this and calculate the final. Then we take the next lowest value and calculate the final. Then we take the next lowest value and calculate the final, next lowest value and calculate the final, until we cannot go any further. Right? Then we just remove this one and then we go on to the next possible value of this until we can do that for satisfying conditions. If that's fine, we go on to the next value. If that's fine, go on to the next. If that is not fine, then now we go on from 2 to 3. Right? So there are a total of 7 ways in which these numbers can be arranged. So the answer to question 53 is 7. Let's do 54. We are given fx is mod x plus 1 and gx is x squared plus 1. hx is max of f and g for x less than equal to 0 and minimum of f and g, which means whichever one is smaller, for x greater than 0. So this question can be very easily solved using the graph. We just map out both the terms mod x plus 1. Right. So what is the graph for mod x? It is like this. The graph for mod x plus 1 will just be shifted by 1. So it will be like this. Both these lines are 45 degrees. This is 1. This is 45 degrees. Right. And we know x square goes like this. So x square plus 1 will go like this. Right. Now, this part I am just assuming. Here we know that the slope of x square plus 1 is 2x, that is 0 at x is equal to 0. Right. And on the positive side, this angle is 45 degrees. This slope is 1. So obviously, this will go below this. This goes below this, right? But fx always has the slope 1. The slope of gx keeps increasing. So at some point, it will be like this. It will intersect it, right? I'll just try to draw the parabola a little bit better. For x greater than 0. Yeah, so this is sort of what the parabola will be like, right? And let's just look at what these 2 points are when they intersect. At the positive side, it will be x squared plus 1 is equal to mod x plus 1, or x plus 1 just because it's positive, which means x square is x, which means x is 0, which is this, or x is 1. So x is 1. At x is 1, the value of y is 2. So this is 2. Similarly, for x is equal to minus 1, the value of y is 2, and this is the other intersection. It should be here. I didn't draw the figure properly. But anyway. Okay. Now we look at hx, which is the maximum value for x less than 0 and the minimum value for x greater than 0. Right. So for x greater than 0, between these 2 points, gx is smaller than fx. The straight line is fx, the curved is gx. Right. So I'll try to use a different color. Between these 2 points, hx takes this value, f. Right, because this is, g, because this is the minimum value. After you go beyond this, the minimum value is given by f. So it will go like this. Similarly, here, x less than 0, you need the maximum value. Between these two, fx has a higher value. So it will be this curve. And after this, gx overtakes fx, so it will be this curve. Right. So this is the curve, and we can now see that it is not differentiable here. You can explicitly check as well. It is not differentiable here, and it is not differentiable here. These two are basically mirror images of each other. Right. This is all symmetric about the y-axis. So this. So just by drawing the graph, we can see that it's not symmetric at these 3 points. Everywhere else, it's not differentiable at these 3 points. Everywhere else, just one function. And this function is differentiable both for x greater than 0 and x less than 0. And the same for this function. This is differentiable everywhere. So the answer to this question will be, there are 3 such points. Let's move on to question 55. Now this is just about as straightforward a question as you can get. There are some tricks which you might use, but you can just start, this goes from 0, so you can just start solving it directly, and that's one easy way you'll get the answer. d2 by dx squared of 1 minus x squared to the power 5 dx. So let's just take this function to be fx. Let's take fx is equal to 1 minus x squared to the power 5. What is f dash of x? It is 5 times 1 minus x squared to the power 4 into minus 2x, which is minus 10x times 1 minus x squared to the power 4. What is f double dash x? We'll just do it and we'll put it inside. Right. The good thing about this integral is there are no denominators or anything. So you can see just from the beginning of the question that you will be able to solve this by the brute force method. There will be no problem along the way. So f dash is minus 10 times 1 minus x squared to the power 4 minus 10x times 4 times 1 minus x squared whole cube times minus 2x. So it becomes plus 20x squared. Right. So f dash x basically is, this is 80. So, and this is q, sorry. So 80x squared times 1 minus x squared whole cube minus 10 times 1 minus x squared to the power 4. 80x squared times 1 minus x squared whole cube minus 10 1 minus x squared whole to the power 4, which you can simplify a little bit further. 10 times 1 minus x squared times 10 times 1 minus x squared whole cube times 8x squared minus 1 minus x squared. So which is 10 into 1 minus x squared whole cube into 9x squared minus 1. So this is a simplified version, somewhat simplified version of f double dash x, which means the integral is the integral from 0 to 1, 4x cube into this, so 40x cube, 1 minus x square whole cube, 9x squared minus 1 dx. Now like I said, you could expand it and solve by the brute force method. It's not going to be very hard. But we can make one small simplification here to simplify it a little bit further, because we can see that all these terms are x square except this one term. We can set x square is equal to another variable t with 2x dx is equal to dt. That would mean integral is equal to, the limits are still the same, 0 and 1. 2x dx becomes dt, so we are left with 20x square, also, which is 20t times 1 minus t whole cube times 9t minus 1 dt, right, which can be written as integral of 0 to 1. 1 minus t cube is 1 minus 3t plus 3t squared minus t cubed into 180 t squared minus 20t. And I'll just expand it completely now, which we would have had to do anyway. Actually, you know what? It might be easier to break it into two integrals. So it's 180 times the integral of 0 to 1 of t squared minus 3t cubed plus 3t to the power 4 minus t to the power 5 minus 20 times the integral of 0 to 1 or t minus 3t squared plus 3t cubed minus t to the power 4 dt, of course, on both sides. So now I'll rub the upper half and just try to simplify it further. So this is equal to 180 times, and the good thing about this is the limits will all be 0 to 1, and 0 will give us 0 everywhere, so only 1 will give us the thing. T cubed by 3 minus 3t to the power 4 by 4 plus 3t to the power 5 by 5 minus t to the power 6 by 6 minus 20 times t squared by 2 minus 3t cubed by 3 plus 3t to the power 4 by 4 minus t to the power 5 by 5, again 0 to 1. So we just need the value at 1, which is 180 times 1 by 3 minus 3 by 4 plus 3 by 5 minus 1 by 6 minus 20 times 1 by 2 minus 3 by 3 or 1 rather plus 3 by 4 minus 1 by 5, and we can just take the LCM in both cases. We will get 3, 4, 5 and 6. We can take 60. Yeah, we can take 60. So then this will be 20 by 60 minus 3/4 will be 45 by 60 plus 3/5 will be 36 by 60 minus 10 by 60 and minus 20 times. Here we can just take 4 and 5 and 3. Again we can take 60. So 30 minus 60 plus 45 minus 12. And this comes out to be 180 by 60 is just 3 times 20 plus 36 is 56. And 45 and 10 is 55. 56 minus 55 is 1. Minus 20 by 60 is 1 by 3 times 30 minus 60 is minus 30. 45 minus 30 is 15. Minus 12 is 3. So 3 minus 1, which is 2. So the answer to this somewhat long question, but simple, not a very hard question, is the integer value 2. Let's move on to the next question, 56. We are asked the slope of the curve, the slope of the tangent to the curve y minus x to the power 5 whole squared is equal to x times 1 plus x squared whole squared, which means y minus x to the power 5 is equal to plus minus root x times 1 plus x squared. And we are also given that it passes through the point 1 comma 3, which means 3 minus 1 is equal to plus minus 1 times 1 plus 1. 3 minus 1 is 2, which means clearly we are dealing with the plus side of the equation. So the equation of the curve is y is equal to x to the power 5 plus root x times 1 plus x squared whole squared. Sorry, 1 plus x squared, that's it. And now we can just find dy by dx. It's straightforward. 5x to the power 4 plus root x times 2x plus 1 plus x squared times the derivative of root x will be 1 by 2 root x. So by 2 root x. And we can just put in the values. The value is 5 plus 2 plus 1 is 2 by 2, which is equal to 8. So the answer to this question is 8. Relatively simple question. The only concept was to figure out whether it's a plus or a minus, and then you needed to know how to differentiate. 57. Largest value of the non-negative integer a, for which limit x goes to 1 minus ax plus sine x minus 1 plus a by x plus sine x minus 1 to the power of 1 minus x by 1 minus root x is equal to 1 by 4. So the first thing we'll just do is write x is equal to 1 plus h, so we can get the limit of h goes to 0. And another thing I'll do directly is 1 minus x by 1 minus root x can just directly be written as 1 plus root x. Right. So we will have, now if x is 1 plus h, is there an a in this question? Hang on. No. Okay. So sine of x minus 1 will just become sine of h, and we will have plus a minus a times 1 plus h divided by sine h minus 1 plus 1 plus h to the power of 1 plus root of 1 plus h, which gives us limit h goes to 0 sine h minus ah by sin h plus h. Right. And now we can just write it as to the power of 2, because h goes to 0, 1 plus h goes to 1, so this is 2. Right. This can be written as limit h goes to 0 sin h by h minus a by sin h by h plus 1. Right, now we know sin h by h in both cases goes to 1, so the answer will be 1 minus a by 2 whole squared. Right, this is 1, so 1 minus a by 2. We are given this is equal to 1 by 4, which means 1 minus a by 2 is equal to plus minus 1 by 2, which means 1 minus a is equal to plus minus 1, which means a is equal to 1 minus plus 1 minus or plus 1, which means a is equal to 0 or 2. So the largest non-negative integer means a is equal to 2. So this is the answer to question 57. Let's move on to 58. We are given fx is equal to cos inverse of cos x. Now the only key concept here is the person setting the paper knew a lot of students might just equate this to x in all cases, but this is only true if x is between 0 and pi. Right, because cos inverse only gives an answer between 0 and pi. Right, so for other values we know what it will be, but it's better to do it by the graph. So from 0 to pi it is x, which is 2 pi, 3 pi, and it is done till 4 pi. At pi, the value of cos inverse cos x is cos inverse of cos pi, that is cos inverse of minus 1, which is pi. Right. After this, the value starts increasing, and finally at 2 pi, cos of 2 pi will give us 1, but cos inverse of 1 should give us 0. Right. So it will come back along this line. and again it will go along this line and it will come back along this line. This is f of x because the answer to the question cos inverse of something, whatever it is, will always lie between 0 and pi. You can try to do it for individual regions. This is the graph that is going to be made. The second function is fx is 10 minus x by 10, which is 1 minus x by 10. So it has a small slope, a slope of minus 1 by 10. At x is equal to 10, its value is 1. When is x 10? That is somewhere along this line. Here its value is 0, sorry, not 1, 0. And when x is equal to 0, its value is 1. This is pi, this will be 1 somewhere here. So the graph basically is like this. Wait, I'll just try to draw a better one. It's something like this, right? So we need the number of points satisfying this equation. So we have 1 point, 2 point, and 3 point. That's it. It would have gone more like this, but the first function is only defined between 0 and 4 pi. So the number of points of intersection are 3. Let's do question 59. For a point P on the plane, let's say the point is h, k. D1P and D2P are the distances from the lines x minus y is equal to 0 and x plus y is 0. We know what the distance from a line is, right? If we have ax plus by plus c is equal to 0, the distance of a point from this line is ax naught plus by naught plus c by root a square plus y square, the mod of that. So d of p1, which is for x minus y is 0, is mod of h minus k by root 2. And d of p2 is equal to mod of h plus k by root 2. And we are only talking about the first quadrant, and the equation is 2 is less than equal to mod h minus k by root 2 plus mod h plus k by root 2 less than equal to 4. This is the equation, right? So obviously in the first quadrant h and k are both positive, so this is always positive. This can take two values, it can be either positive or negative. So case 1, let's say h is greater than k. It means 2 is less than equal to, now it will be h minus k by root 2 plus h plus k by root 2 less than equal to 4, which means 2 is less than equal to, k and k will cancel, 2h by root 2 or root 2h less than equal to 4, which means root 2 less than equal to h less than equal to 2 root 2. In the second case, if k is greater than h, we will have 2 is less than equal to, now this is k minus h by root 2, the distance, plus h plus k by root 2 less than equal to 4, which means 2 is less than equal to k by root 2 plus k by root 2 or root 2k less than equal to 4, which means that root 2 is less than equal to k is less than equal to 2 root 2. Right, so these are the two important equations. Now we are asked that the area of the region are consisting of all these points in the first quadrant. So now we can just solve it by graph. So I'll just keep these equations and leave everything, rub everything else out, because the area can quite easily be seen by the graph. So first of all, we are talking about the first quadrant. Secondly, there are two cases. This was h greater than k, this was k greater than h. Right. This is the line y is equal to x. Any point on the right side of this line has an x which is greater than k, or h greater than k. Right. So on the right side, this equation should be followed. H is between root 2 and 2 root 2. This is root 2. This is 2 root 2. So for the right side of this equation, h should be between root 2 and 2 root 2. So this is the amount of area. It has to be in the first quadrant. X has to be between root 2 and 2 root 2. But it also has to be on the right side of this equation, or on the down side of this equation. The points on the left or the up side of this equation are points where k is greater than h. There you have k being between root 2 and 2 root 2. That means k is between these two values. So this is the other part. This is the total region whose area we have to find out. So we can just do it geometrically. These are two identical trapeziums. So the area will be 2 times the area of any one trapezium, which is half into the sum of the parallel sides. This is root 2 and this is 2 root 2. So the sum of those will be 3 root 2 into the distance between the parallel sides, which is root 2. So 2 and 2 cancel. We have 3 into 2, which is 6. So the answer is the area of this region is 6 square units. Let's do the final question of this paper, question number 60. We are given A, B and C are three non-planar unit vectors such that the angle between every pair is pi by 3. So this is something we've seen before in this paper itself. Mod A is equal to mod B is equal to mod C is equal to 1, and A dot B is equal to mod A mod B cos of 60 degrees. In that question, all of them had a mod root 2, which is equal to 1 by 2. So A dot B is 1 by 2, B dot C is 1 by 2, and C dot A is 1 by 2. Right. We are given that A cross B plus B cross C is equal to PA plus QB plus RC. Right. And P, Q and R are scalars, and we have a particular equation whose value we have to find out. Right. So we can do this in a number of ways. A nice way is to take the dot products with different vectors. So you can take the dot product of this whole equation with A, B and C, and it will give you 3 results. If you take the dot product with A, this term will have a dot product with A which is 0. So A dot B cross C is equal to the dot product of A with these terms. So P, the dot product of A multiplied by the dot product of A is just 1, plus Q. Now dot product of B with A is B dot A is half. So plus Q by 2 plus R by 2. Right. This is A dot B cross C. Also, if we take the dot product with B, this side will be completely 0. This is equal to P by 2 plus Q plus R by 2. And then you take the dot product with C, you'll have C dot A cross B, which is the same as A dot B cross C. That is P by 2 plus Q by 2 plus R. Right. So these 3 equations we have. We can equate the first and the third. So we get P plus Q by 2 plus R by 2 is equal to P by 2 plus Q by 2 plus R. Q by 2 cancel. We get P by 2 is equal to minus R by 2, or P is equal to minus R, or R is equal to minus P. We'll put it everything in terms of P. So R is minus P. You put it in the second one, what you get is P by 2 plus Q minus P by 2 is equal to 0. Sorry, minus P by 2 plus Q minus P by 2 is 0. Hang on, I made a mistake. This is R minus R by 2, so this is positive R by 2. So P is equal to R, right? And so this will be plus P by 2, which means P plus Q is 0, so Q is equal to minus P and P is equal to R, right? I made a mistake of a minus sign here. So these are our 2 results, right? So after that it's quite easy. We are just asked the ratio of sum of these. So the thing we are asked, we can write it as P squared plus 2Q squared, we can just write as 2P squared, plus R square, again we can write as P square, by Q square, which is just P square. So it comes out to be 4. So the answer to question 60 is the integer value 4. This completes the solutions paper 1 of JEE 2014 Advanced Maths part. Thank you.